Hello everybody and welcome to 1-1 Patterns and Expressions. Let's get going. Start off with the very first thing, which is patterns. Patterns are seen throughout the world, whether it's man-made or in nature, has a purpose for looks like birds, flowers, or snakes, or for structure like a brick house or a beehive. Patterns will always be useful. In math, there is no difference. If you can figure out the pattern, it will always help finding the solution that much easier. In other words, take a look at the first 4 questions, for instance. If I were to ask you, give me a day of the week, a month of the year, a color, or some sort of shape, the chances of you getting all those questions correct will be kind of difficult. You see, you have a 1 in 7 chance to get the day correct. You have another good chance with a 1 in 12 to get the month. But if I said for you to pick a random color and hope that I get the correct answer, it's probably not going to happen. And the same thing goes with a shape. So using the patterns previously given, you'll find out that the answer is actually pretty easy to find. Like Monday, Wednesday, Friday, Sunday, Tuesday. Each and every one of these days is increasing by 2 days. So what is 2 days after Tuesday? That's right, Thursday. Sorry for the handwriting. January, April, July, October, January. Well, January is right here. It's up here. What follows January? April. Makes it nice and easy. Red, blue, red, yellow, red, blue. My instincts is going to go red one more. There we go. Circle, square, triangle. Circle, square, and once again, I'm also going to be doing triangle. All right? Perfect. Now, like I said before, some math patterns are easier than others, but once the pattern is figured out, then the answer will always be easy, no matter how difficult the pattern truly is. Like in questions 5 through 7. The very first pattern, 2, 4, 6, 8, you almost immediately jump into 10, because every single time it's increasing by 2. 6 becomes a little bit more challenging because instead of increasing, which is what we're known to do, it's decreasing. So you go down, it looks like 3. 6 to 3, 3 to 0, 0 to -3, -3 to -6. But 7's a truly difficult one because it doesn't seem to be going up at the same rate like number 5 was, and is clearly not going down like number 6 was. So we have to start thinking outside the box. How do you get from 2 to 8? More importantly, 8 to 32. My first gut instinct is I'm multiplying by 4. Well, from 8 to 32, again, you're going to multiply by 4. And 32 times 4 will give you the 128. And now we have our pattern. So the last one should be 128 times 4, which is 512. Pretty simple, right? Which brings us into the next section of numerical expression and algebraic expression, which also poses the one major question, that is, what is the difference between expression and equation? The only difference is the equal sign. You see, an expression is just some sort of mathematical statement. Alright, that means it could have numbers, variables, it could have mathematical operations altogether, like adding, subtracting, multiplying, dividing, whatever it may be. Whereas an equation has all of that, but the difference is the equation has an equal sign. In fact, the equation is an expression equal to another expression. But let's talk about the numerical expression. What makes something a numerical expression? Well, numerical just means it has numbers. The expression, like we said before, is just a mathematical statement. So it's a number-only mathematical statement. Algebraic means that we're going to be tossing in some variables. So looking at questions 8 and 9, they're both kind of asking the same question, right? Because if it's a numerical expression, that means that it doesn't have any variables. In other words, we're looking for some variables. So the very first part, 5x, we know is going to be algebraic. Why? As a variable. 3 plus 5 over 2 is going to be numerical because there is no letter, there is no variable. We have a z right there, so this is algebraic. And yes, even having an r, or a variable, in the denominator spot still allows it to be algebraic. Can you circle the variables for the algebraic expression? X, W, D, V, K, and Q. And notice, I'm not taking the constant in anything, meaning I'm not taking the number that is next to the variable. I'm strictly accepting the variable. I've been talking for quite some time, so let's give you guys a very short break. Let's see if you guys can check your answers, make sure all your answers are correct, and I'll get back to you in the next section. Taking a look at this, how many white squares do we have in the very first figure? Well, you got 1, 2, 3, and 4. So the answer should be 4. There are how many more white squares in the second figure? If I were to pick up this figure and place it on top of the second figure, you're going to notice that everything that is shaded will be now the original figure. So the squares on the outside are the new squares. And again, we have 1, 2, 3, and 4. The very next one, we'll be knocking off 2 white squares from each. And once again, around the outside, you have 1, 2, 3, and 4. So it looks like the pattern is 4 more white squares. Describe the pattern. You can just say that you're just simply adding 4 more white squares. Adding 4 more white squares each time. But if I know that that is the pattern, then number 13 becomes that much easier. So if I wanted to do 13, I can immediately take a look at it and know that I'm just going to have to add 1 more white square. Very simple. Number 17, circle the description of the input value, underline the output. Well, the output is the same thing as the y value, and the input is the same thing as the x value. So looking at the graph given, I know that the x value is the number of Pallades. So I'm going to circle number of Pallades. Now I have to underline the output, which was total cost. Total cost. Now that we know the input and the output, I can type them in. Number of Pallades. And the output, total cost. So let's start plugging things in. If the input is 1 and the column is 1 times 2, then the output must be 2. If the input is 2 and the process column shows that we're multiplying by 2 originally, the input of 2 needs to go here, making it 2 times 2, which equals 4. The input value always seems to be the first one, so that is a 3. So I'm going to put a 3 over here, and we're always again multiplying by 2. 3 times 2 is 6. Good. Input of 6. Original parameter of times 2 gives you the output of 12. There we go. So the input is n, which is the first spot. The parameter was times 2. Therefore, the output is going to be 2 times n, or 2n. In the table, when the input value is 6, the output value was 12, like we've shown. Well, 2n describes the cost of n Pallades. At the aquarium shop, 6 platies costs this much dollars. Well, we already answered that question when we said that the input value of 6 gives you the output of 12. So the answer is $12. And as you can see, we have our outputs, which is 2, 4, 6, and 8. Starting with 1, 2, 3, and 4. We'll call this our x value. We'll call this our f of x value, or y value. And then we need to determine how do we get from 1 to 2, 2 to 4, 3 to 6, and then 4 to 8. Well, so we need to figure out the process. Well, to get from 1 to 2 and 2 to 4, it looks like we're multiplying by 2 each time. So I'm going to take the input and multiply it by the parameter, which is 2. Again, the input times 2. Once more. And then if I were to make the algebraic version with using the variable n, you would again get n times 2, which would then turn to 2n. Now I'm going to allow you guys to work on this on your own, but I will say this. The very top shows that this is going to be 3, 6, 9, there you go, and 12. Error analysis. Your friend looks for a pattern in the table on the right and claims that the output equals the input divided by 2. Is your friend correct? Well, right off the get-go, we know that the friend isn't correct because 3 divided by 2 does not give you 2. But does it apply to most? And it does, in fact, apply to most. So yes, I will say that the output is equal to the input divided by 2 for most. He's absolutely right. However, does the input value of 3 follow this rule? No, it does not. And since it does not, there is no pattern. Does the table represent the pattern? No. Because the very first input and output does not follow the pattern. Congratulations everyone, we made it to the end. I do apologize for my monotone. I promise I'll try and do a little bit better with that in the future. But hopefully you can check over your answers one last time. Make sure question number 23 is correct because you should have hopefully done that on your own. And have a good one and keep doing you.